Welcome to the series where we are trying to understand the history of Lakehouse. Why we have come up to the concept of Lakehouse today. Everywhere we see on any platform, whether it's Microsoft Azure or Amazon um, Amazon Web Services, they have lakehouses. But do you know who is the pioneer of Lakehouse? It is Databricks. Databricks has coined the concept of lakehouse, and it was the Databricks platform on which it was implemented for the first time. We will start from the history. We'll go through what are the nuances of Lakehouse. We'll also come to the point where Databricks is now enhancing the Lakehouse into data intelligence platform. And finally, we'll see the business applications of Lakehouse. So let us begin. First of all, we'll see how Lakehouse started. This was a time when data was extremely simple. Like around 20 years back, let's go 20 years back, where we used to have a simple data where rows and columns would be dominant, and the data was coming from a transactional system, and therefore uh, invoices, payroll entries, that kind of data it was coming, and it was a very neat and tidy and predictable data. If it was not predictable, we would simply discard it. So business leaders could ask questions directly in the form of SQL and get an answer that makes sense. So for more than 2 decades, even today, warehouses are ruling to some extent, right? So these systems that we used to hear about is like Teradata, Oracle, IBM, Netezza, and Snowflake and BigQuery. So all these were based out of processing the structured data. Structured as in we would have something in the form of rows and columns similar to Excel. But then the world changed. What happened is a digital revolution. So sometime around 2010 or so, digital revolution happened. So everyone was having mobiles in their hand. The system size exploded, and the systems became like a massive systems. So they started generating huge amount of data. Smartphones were generating data, sensors in the factories were generating the data. Social media eruption started, like starting from Facebook to even up to Instagram and WhatsApp today. So all those kind of things started. So suddenly the data, if we start handling such data in a structured way, people realized that it was not possible to handle it. The data was alive, unbounded, unstructured, and arrived in every millisecond. Organization has become proud of their carefully tuned warehouses. They were proud of their warehouses and suddenly found themselves in panic. The warehouses, once their fortresses of insight, became a bottleneck. It's a great saying that I have put in the article. Like a photo uploaded by a customer or a product review in a natural language, a real time temperature reading, all those things, none of that could fit in a warehouse schema, and therefore I would say like this, that it was like trying to pour an ocean of a data through a coffee filter. So warehouses became that kind of a bottleneck, completely sabotaging the plan to create insights from the data. So there comes the data lake dream. So people started moving to from warehouses to data lake. Now, what is the advantages of data lake is? So what is the data lake first? So data lake is built on promise of cheap cloud storage with open file format. So they said that okay, you are a bottleneck because of the storage format, right? Like you are having structured data and all. So let's move to a system where there is no structured data. So they moved to data lake. Data lake's main concept was trying to put everything in a cheap cloud storage, and file format needs to be open so that any kind of data can come in and get stored, whether it's a CSV, JSON, images, log streams, click streams, uh, any kind of data. No structure. Like I still remember there were um, databases like MongoDB was very famous because it doesn't need you to have a structure of a data. Then such kind of databases started propping up, and data lakes actually started propping up, and they were very famous for quite some time. So for a moment it felt liberating. Engineers could capture data in raw format, data scientists could experiment freely. But soon this entire story turned differently. The data lakes became data swamps. There was no schema, no governance, no guarantees, and therefore uh, queries failed, job conflicted, and there were multiple copies of data, and no one was ready to take a guarantee of such data. So, without rules, without transaction, without consistency, the data lake became digital wilderness. So, that was the story. So, we came from warehouse, there was chaos in the warehouse, and therefore we came up to data lake, and now data lakes are turned into data swamps. This is another great concept called the Great Divide, BI versus AI. So in 2010, BI was prominent. So we used to have every company used to have something like uh, something like a BI framework and a warehouse to create the insights. On one side, BI teams who lived in the world of dashboard metrics and KPIs, they still dependent on the clean structured data. They needed that warehouse. Therefore, every company around 2010, we used to see that okay, there used to be a macro strategy, Power BI, and that kind of a framework for insights backed by a warehouse. On the other side, the data scientists and AI engineers cannot cope up with such kind of a structured data because they need to run the simulations. They need to read the data multiple times. They need to increase the size to some n extent so that they could derive the insights of it. They need to do the regression. Lot of compute is needed. So for such cases, it was not possible to do with the kind of a uh, kind of a warehouse. It was not possible. So the two worlds spoke different language, used different tools, and rarely met. And therefore, what happened is the main problem silo. The two departments were acting in a silo, and therefore sometimes it used to happen that the conclusions are differing. Your BI team is saying something, and your AI team is a different insight. Maybe because underlying they are not using the same data, and therefore this is a problem. So executive wanted one answer, one source of truth, and one architecture. Instead, they got two parallel universes, and that was the biggest challenge. Why warehouses couldn't keep up? To understand why warehouses eventually broke, we must look under the hood. Traditional warehouses were designed for a schema on right philosophy. You decide the structure before loading the data. As I said, it's a structured schema approach, and therefore you need to have a data in the right format. That worked when the data was predictable, but it collapsed with new data types. The economics became unsustainable, and the technical constraint became painful, and the innovation cycle also slowed to crawl. Companies started realizing that their shiny warehouses, once the source of competitive advantage, had turned into anchor holding back their data strategy. Why even the lakes were not the answer? Because the data lake, for all its openness, has its own flaws. As we already seen, it doesn't have ACID transaction, there is no schema enforcement, and therefore it was not possible to trust on them. But there is a famous saying that says that we have petabytes of data, but no one dares to use it in production because we didn't had any trust on it. So having repeated what was the problem, let us understand, because of these two problems of warehouse and lake, how the lake house has come into picture. So there is always this combination of warehouse plus lake house converting to lake house. Let me quickly show you the lake house image, which I always show to everyone. So this is the story of how lake house came into picture. Let me quickly bring that picture up. So this is how it used to work. So data warehouse would have BI reports backed by a warehouse. ETL used to happen and it used to be a structured data. So this is the story of a warehouse. And then data lake is something in which BI and data science people used to work together. They would go back to the same source of truth, which is a data lake, backed by the um, cheap storage, cheap cloud storage. And then we would have something like data. And finally, we have data lakehouse, which has come out of the um, limitations of data warehouse and data lake. Let us understand the birth of lakehouse vision. It was inevitable that the two worlds, warehouse and lakehouse, wouldn't collide. So somewhere we have to uh, bring down that missing piece of a puzzle. An architecture that could handle structured, unstructured, both type of data, support analytics and AI, and still enforce the governance and reliability. And this was the birth of data lakehouse. The idea was radical in its simplicity. Keep the low cost scalable storage of a lake, add a transactional reliability of warehouse, and build on open standards. The transactional reliability means governance as well. So technologies like Apache Spark, Delta Lake, and later Databricks Unity Catalog turned this vision into reality. So Lakehouse is not something that you would go and see, okay, this is my Lakehouse, this is how it looks like. It's not like that. It's a concept which has been fulfilled by these multiple products coming together on the Databricks platform, like Apache Spark, Delta Lake, Databricks Unity Catalog. All of these guys come together. So for the first time, you could run SQL analytics and machine learning on the same data, in the same platform and without duplication. The Lakehouse wasn't just a storage layer, it was a new philosophy of data management, open, unified, and intelligent. This movement matters. So every major evolution in data architecture has been from a crisis. The data warehouse solved the problem of fragmented reporting. The data lake solved the problem of storing raw unstructured data, but Lakehouse now solved the problem of integration and intelligence. Let us see how the data lakehouse looks like. Okay, we have seen data warehouse, data lake. The lakehouse came with the concept of serving through a single layer with all the possibilities. Let's say this way. Okay, so data lakehouse is serving BI reports, data science, and machine learning. Everyone backed by a common metadata and governance layer, which is a unity catalog, which is a spinal cord of your entire lakehouse, with storage on cloud and on open format. So this is how it works. Okay, so this is the storage and everything open format. There is a unity catalog governance structure, and finally it has a serving layer. So this is how it works. This is the simplest picture of a lakehouse, where we have SQL, Lakeflow, dashboarding, AI, everything being served through a common governance layer and data formats. So this is what we call it as a lakehouse. Okay, so now you have a picture, like when we used to picture the warehouse, we used to see like some database kind of a symbol, right? And when we used to see lakehouse, data lakes, we used to see some data lake kind of a symbol. So when you think of lakehouse, you should bring this picture into your mind, where you have a serving layer, a unity catalog, and an open format of a data. The same platform that powers your dashboard also fuels your machine learning model. Your BI AI teams no longer work in isolation. They have a common data set to pick. And perhaps the most important is the cost of insight dropped dramatically because you no longer have to maintain multiple systems, multiple copies, and multiple contracts. A new chapter begins. The journey from data warehouse to data lake to lakehouse mirror the evolution of business itself, from control to exploration to intelligence. Today's lakehouse is more than just an architecture, it's a nervous system of modern enterprises. It is where the data becomes reliable, accessible, and intelligent, ready to feed every dashboard, every algorithm, and every AI agent that powers decision making. So, all those who work in industry today realize or already know that warehouses are not the game, data lakes are not the game, but lakehouse is something that they need to learn and implement. In those who work on the Microsoft platform, they have their own version of the lakehouse present. On AWS cloud, they have their own version of lakehouse, but the best lakehouse is implemented by Databricks on Databricks platform. And as I mentioned, as a last picture that you see, you should always concentrate on this kind of picture which tells you the story of a lake house. So this is another picture in which we have this Databricks Lakehouse platform. So this is another picture where we always showcase how the Databricks Lakehouse looks like. Let me just try to zoom out, zoom in. Yeah. So Databricks Lakehouse platform has warehousing, engineering, streaming, and machine learning, everything combined at the serving layer with Unity Catalog governance layer and data stored in cheap cloud storage. So this is the story of a lake house. Every engineer, every computer science engineer, or every engineer rather, who want to join in into any technology company for data and AI must have this information of what is a lake house. In the next upcoming video, we are going to understand how Lakehouse internally works, how Databricks has turned it into a data intelligence platform, and what are business cases are possible on Lakehouse. So thank you guys for listening to this. Uh, Please do subscribe. I'll put more videos on it uh, on Lakehouse, and then we'll also plan to take it further to show you an actual implementation. Thank you. Thanks.